Hey, AB Stats, today what we're going to do is we're going to draw some conclusions about a population, right? In statistics, that's our goal. We're always taking a sample, we're drawing conclusions about a population, and then we're making decisions. Today, what we're going to learn is we're going to learn something called a confidence interval. What is a confidence interval? Well, a confidence interval we use when we want to draw conclusions about the population parameter. What is a population parameter? A population parameter is something that's describing the population. So we've been talking about it in semester one is the true mean of the population or the true proportion of the population. Now, in this case, we don't know what that parameter is. So we use a confidence interval to try to estimate what that parameter is. We're going to grab a sample. We're going to build a margin of error. And from there, we build this interval using the statistic and the margin of error. We're going to get a lower bound. We're going to get an upper bound. And in there, we're going to be really confident that the truth is somewhere in that interval, the true population parameter. Let's get going with this. I want you to start getting familiar with your formula sheet. You're going to be building several confidence intervals in this class. If you look at your formula sheet, they do give you the confidence interval, just general formula. You see we have the statistic plus or minus a critical value times the standard error of a statistic, okay? Well, today we're going to be dealing with proportions. The statistic for a proportion, what's describing the sample, is your p hat, okay? So when we talk about this statistic, we're going to talk about p hat, and you can see that right there. Here is our statistics. My daughter's playing Legos in the background, so if you can hear her rummaging through the Legos, I apologize. Here's our p hat, and we find that, just a friendly reminder that a p hat is part of the total sampled. Okay, part of the total sampled. And we find that, or it's given to us. No matter what, though, the p hat describes who has been sampled. Next, we have something called a z star. That's our critical value. I'm going to show you how to find that z star in the problem next. And now okay, the old formula sheet, you said standard deviation. Now it does say standard error. A standard error now is just a little bit different than the standard deviation of the sampling distribution. How is it different? You'll notice here it's p hat instead of p. It's just an estimate of what the standard deviation would be for that sampling distribution. The reason we have to estimate it, guys, is we don't know what p is. We have no idea what the true proportion is. We're trying to estimate that by coming up with a confidence interval. So here, right here, guys, here's our formula for our standard error, okay? Now, in order to use this formula right here, we have to have some conditions that are met. And like I would joke if I'm in class and try to be funny, I'm probably not, but I would say we're not gonna go for a run, we're gonna go for a rin, okay? Here are 3 conditions that we need. We need a random sample of n equals blank. So we're gonna label what that is. That independence condition, okay, that means that our sample has to be less than 10% of the population. So how I find that then is I take 10 times my sample size has to be less than capital N, my population size. And then we deal with the normal condition. This is the same that we just used from our last unit. Not n is greater than or equal to 30. That's for means, but our NP. Okay, so n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. Now, there's an issue with this, right? This is the condition that you know from Unit 5. However, we don't know what p is. We do not know the truth. So we have to take our p hat for the normal condition for our interval. When we've met these 3 conditions, we can go ahead and we can use this formula. We have our statistic. This right here, ladies and gentlemen, this is our margin of error. Our margin of error is equal to z star times that standard error of the statistic, so p hats, times 1 minus p hat over n. So we have this statistic, we add the margin of error to get our upper bound, and we subtract the margin of error to get our lower bound. This right here then is our interval, and we are very confident that somewhere between the lower bound and the upper bound contains the true proportion of whatever we're trying to find. Let's go ahead and practice it right now. We want to estimate the proportion of Philadelphia families with children enrolled in preschool. In a random sample of 50 Philadelphia families with children of preschool age, 35 had children enrolled in preschool. Find a 95% confidence interval for the current true proportion of Philadelphia families with children enrolled in preschool. Okay, I will say identify the parameter, blah, blah, blah. I'll talk all about this. But at first, let's just talk about what we notice here. Right here, this 50. I always like to highlight this at the beginning. What are we working with here? This is our N, okay? This is our sample size, 50 Philadelphia families. Right here, 35. This is our part of the sample. We're going to call the part X. Then we're going to call P hat X over N. We're going to go back to the state plan do conclude model that we've been using. Okay, let's get going on this. I'm going to cover some things up here. Give me 1 second. Okay, if you haven't had me before, what I'd like to do on your notes, and you can print this off, I'll have this for you to print, but if you don't have a printer at home, I like to break it up 2/3, 1/3. So on the third of the section right over here, this is the direction of what you need to do whenever you're finding a confidence interval over here. And then on the left side, this will be matching for the problem. So it will apply to what's going on in the actual problem. Generic, specific to the problem over here. In the state step, what am I going to be grading? I want the parameter that you are trying to estimate. Today, we're only dealing with proportions. So today, it will always be P equals the true proportion of, and then you fill in the context here, okay? What is our context? They tell us in this problem here. An interval for the current true proportion of Philadelphia families with children enrolled in preschool. So I shortened it up a little bit, FAMs with kids enrolled in preschool, mainly just so you're not writing as much, okay? Take a second, pause, get this down. This is important. The next part is the plan. Hopefully you are used to now the conditions. We need to go for a RIN, right? We need to go for a RIN. There's one other thing you're going to need in this plan. So you need to do the conditions. That is our RIN. But you also have to say, okay, our conditions are met. Now what are we going to do? What method are we going to use to draw conclusions about this population? So there is our method right there, okay? Conditions and method, and I'll talk about what you're going to write down for the method. Our conditions, we're going for a RIN. R, what does R stand for? Remember, that's our random sample. Do we have a random sample? And we can assume this as well if we need to. But it does state a random sample of 50 Philadelphia families. So there is our R. Stated random, N equals 50. Next is that independence condition. 10 times the sample size has to be less than the population size. Here we go. 10 times 50 has to be less than not the 50 Philly families, but all Philly families. Next is our normal condition. Now remember that normal condition, I can't use P because I don't know the true proportion. I'm trying to estimate it. So I'm going to need to use P hat. So we need a little side work, right? Because P is unknown. So what is our side work? P hat then? Well, that's equal to 35 out of 50. We already talked about that P hat is equal to that part over the total sampled. Okay, next then, let's go ahead. Let's do that normal condition right there. The N times P hat is greater than or equal to 10. That is true. And then N times 1 minus P hat is greater than or equal to 10. We have satisfied our conditions, and now we're ready for our method. And what method are we using? We are using a one sample Z interval for P. Okay, pause right now, write down anything that you don't have written down, rewind, slow it down, whatever you need, or continue to go on to the next step. We have the state, we have the plan. Now we're going on to the do. Give me a second here. Oops, spoiler alert. See if I can move it over. There we go. And I didn't want to do that. Okay, what do you need in the do? In the do, I have two of these, I don't need that, okay? You need to write out the formula we just wrote out, and then we need to plug the numbers in, okay? So we already have this written out on the first page. We take our statistic p hat plus or minus our critical value times the standard error of the statistic. So p hat times 1 minus p hat over n. We know what our p hat is. That's 35 out of 50. So we can fill that in. P hat here, p hat here, p hat here, and we know what n is. What is this z star, this critical value though? I need you to get your formula sheet out, and if you don't have your formula sheet out, I need you to maybe Google AP Stats formula sheet, or you can go on our Schoology. I'm going to show you right now where to find it, but you have to be very, very fluent with this formula sheet and where to find your critical values. If you look at your formula sheet, we are going to go to page, oh, it doesn't have a page number in there, shoot. Okay, we're going to table B. Okay, so I want everyone to find table B right now. Pause, find it, and then I'm going to show you where we're going to go. Okay, what I want you to note is down here, you see these different confidence levels. This is how confident we are that the interval from the lower bound to the upper bound contains the true parameter. So this problem asks us for a 95% confidence interval. This row right here, whoops, not the two, the bottom row right here, these are our Z star critical values. So our Z star for 95% is 1.96. If we were asked for a 99%, 0.8% confidence interval, our Z star would be 3.091. If we wanted a 70% confidence interval, our Z star would be 1.036. But we want a 95% confidence interval, so that is 1.96. We're going to go ahead, watch that again if you need to figure out how to do those critical values. But now what we're going to do is we're going to go ahead and we're going to plug in everything that we know. 35 over 50 plus or minus 1.96. I'm plugging it all in. This is the work that will be required on the test to get full credit. If I don't see 1, 2, and 3, you will have lost 3 points. Now what I want you to do is get your graphing calculator out. We could calculate this by hand in our calculator, but the graphing calculator is a very nice feature for you. So go ahead and pull out your TI. It's either on your Chromebook or you have your own handheld one. I'm pulling mine up now, or I should have. Okay, so on our graphing calculator, if we look, again, I'm not patient sometimes, I'm sorry. Oops. I'm now going to go to Stat. This is considered a test. These are all of our different methods we're going to use to draw conclusions about our population. So we're going to arrow over to tests. What we're working on right now is a Z interval. Let's just go ahead and let's look at all of these here. Lots of different tests we're going to use. Okay, but we are doing a one proportion Z interval. We have one sample or one proportion that we're looking at, 35 over 50, and we're going to hit enter on one prop Z interval. Here is our X, that's our parts, 35, N of our total sample, 50. And now it wants to say, well, what is our confidence level that we want? Well, that's 0.95. And we're going to go ahead and we're going to enter on calculate. So you can see here, guys, we have our lower bound and our upper bound, 0.573 to 0.827, okay? 0.573 to 0.827. I usually like 4 decimals. AP does accept 3. I must have been lazy or something when I filled this out. So what does this mean, guys? This lower bound. We're really confident now. Hey, we want to know the true proportion of Philadelphia families who are enrolled in preschool. We're really confident. In fact, we're 95% confident that it's anywhere from 57.3% to 82.7% of Philadelphia families have enrolled their kids in preschool. So now what we need to do then is we've used our calculator and we've calculated the lower bound and the upper bound. Okay. One thing that I want you to do is rewind just so you can see how we got there again. We went to stat, we arrowed over to tests, and we go to that one prop Z interval. You want to become one with your calculator, very fluent with this calculator, okay? The last thing that we want to do right now is we need to do the conclude, okay? I have a template for you down here, and we want to, this is like a fill in the blank. We want to use it always, okay? Now, when you conclude, you're interpreting the interval only. You interpret the level only when asked, and I'll talk about the difference between that here a little bit later. So what are we? We're 95% confident that the interval from 0.573, that's our lower bound there, to 0.827, that's our upper bound, contains the true proportion of families with preschool age kids whose kids attend preschool. Use the question to help with context if you need. If you go up here, it's saying find a 95% interval that contains blah, blah, blah. Use that to help you if you're struggling with the context. Okay, so we have concluded our interval. This is part 1. I'm going to do one more part with you guys here, but this is the first, a big part. Congrats on your first method you learned for inference. Oh my gosh, wasn't I recording? Where did it go? Am I still recording?